Hello everyone, we are Team 13 and we will be presenting the Rehab Walk, or the R-Walk for short. This is a rehabilitative device which is used to decrease the energy expense of walking and to strengthen muscles. This is a biomedical engineering project and was developed with the help from our advisor, Dr. Kristen Morgan.
For injured individuals and the elderly, walking becomes much more difficult and energetically expensive due to muscular atrophy over time. In order to mitigate this, our goal is to create an assistive rehabilitative device that functions to delay muscle wasting by increasing the activity of the quadriceps and hamstrings while walking. In order to accomplish this, our device utilizes a system of bands and pulleys to increase muscular activity.
The final design evolved quite a bit after some preliminary testing. It consists of a training belt, a knee strap, 2 pulleys, a rope elastic system, and supporting 3D printed parts. The belt is fitted above the hips, and the knee strap sits below the kneecap of the injured leg. Pulleys are placed on the belt in the front and the back. Then this rope elastic system is fed through the 2 pulleys. After testing a couple of different orientations, this design has the elastics lay on the front and the back of the thigh, parallel with the leg. The elastics create resistance to provide alternating tension to the quadricep and hamstring muscles, and the pulley allows for the rope elastic system to actually move smoothly while walking. Many 3D printed parts actually hold the device together, like this pulley holder and these connectors. Here's a video of the device in action.
For our results, data was collected in Dr. Morgan's Human Performance Lab on multiple subjects. There were 3 metrics that we chose to focus on: EMG, stride time, and linear loading rate. For the sake of time, we chose not to focus on EMG. However, the main takeaway is that the device has the potential to increase muscle activation. As far as stride time, this graph shows the average stride times for trials of different walking speeds and different device configurations noted by the legend at the top. The error bars are based on the standard deviation for each trial type. Looking at each set, with the green being the control data, you can see that for each walking setup, there is in fact a decrease in stride time. This means that the device causes the user to walk faster, promoting more stable gait patterns. Linear loading rate refers to the amount of ground reaction force applied per second from initial contact of the foot to the first peak. This phase of gait is known as the loading response. A lower linear loading rate demonstrates greater control of motion. Though not for all trials, there was a decrease in mean linear load rate when the right leg was set to a faster speed. This is promising because the device was worn on the right leg.
The R-Walk has evolved in many ways over the course of both semesters. This device was created from scratch. From beginning with a single pulley, a handmade belt and knee strap, rope, and a flat exercise band, the device improved to its final design, including 2 angled pulleys, a thick and comfortable waist belt, a comfortable and sturdy knee strap, and a rounded band material. The final design is minimal and easy to use with multiple adjustable components. Many iterations of all the components of this device were created. All of the attachments were designed from scratch and 3D printed. Up to 6 iterations of each piece were created and over 30 different parts were printed over the course of the design process. Pictured are a few of the parts, including an angled pulley holder, the band and rope connector, and the adjustable and detachable knee connections. There are components of the project which could be improved or further worked on in the future. The group got really far in developing the device, however, further testing was still needed. As the group was only able to conduct a few motion capture and EMG trials, additional time to conduct more trials would have helped to better analyze the device and how it altered the mechanisms of walking. This testing would have also aided in developing the adjustability feature of the R-Walk, as it was desired to have multiple band strengths available to the device, which would have been utilized according to one's leg and body strength. Finally, in order to maximize the effect of the R-Walk device, it was also desired to create a locking mechanism. The group was able to begin the brainstorming process of this specific component. However, ultimately, it was not developed due to time restrictions as well as due to the complexity of developing the R-Walk device itself from scratch.
The R-Walk is a device that will help to strengthen muscles while walking. We see this device working to reduce return to play time for athletes who are injured while also increasing the ease of walking for individuals such as seniors who face muscle wasting as they age.